Good morning. Welcome to another edition of A for A levels. This is my tutor. Today we're going to go through paper 32 of summer 2020. Let's go. Find the quotient and remainder when 6x power 4 plus x cubed minus x squared plus 5x minus 6 is divided by 2x squared minus x plus 1. Okay. So what you can do is you can do a long division. A long division would be better in this case. Okay, long division. 6x to the power 4 plus x cubed minus x squared plus 5x minus 6. 2x squared minus x plus 1. When you do this, you got to be careful. So in order to get 6x power 4, you must times by 3x squared. So 6x to the power 4. X times 3x squared is 3x cubed plus 3x squared. Okay, so minus x squared minus 3x squared is 4x cubed. Sorry, cube. Minus x squared minus 3x squared is minus 4x squared. Bring down the 5x. Then you must times by 2x plus 2x. Okay, so 4x cubed. X times 2x is 2x squared. 2x minus. So 4 minus 4x minus plus 2x is minus 2x squared. 5x minus 2x is 3x. Bring down the minus 6. Here you just times by minus 1. Okay. So minus 2x squared minus x times minus 1 is plus x. 1 times minus 1 is minus 1. 3x minus x, 2x. Minus 6 minus 1 is plus 1 is minus 5. So this is your remainder. This is my quotient. Okay, that's it. Next. The variables x and y satisfy the equation y squared equals to a e to the power of kx, where a and k are constants. The graph of ln y against x is a straight line passing through the point as shown in the diagram. Find the value of a and k. So what I'm going to do is I'm going to first change the equation to the linear form. This is an easier way, huh? So you log both sides of the equation. Ln y equals to ln a plus ln e kx. Okay, and then divide by 2. So you have ln y equals to ln e kx is just kx. Divide by 2 is k over 2x plus half ln a. Okay. This is in the linear form y equals to mx plus c. Y is the vertical axis ln y, xs, the horizontal axis, which is just x. So the gradient is k over 2 for the graph. So k over 2 equals to 2.7. Yeah, 2.7 minus 1.2 over 5.24 minus 1.5. Calculator. Okay. Let's get the calculator. 1.2, 5.24 minus 1.5 divided 2. So 2 decimal places, 0.20. Okay. 0.40. Okay. 0.80. So K is 0.80. Okay. Now, by substituting the values of the coordinates, you can find what is the intersect. So you're going to take the point 1.5 and 1.2. So 1.2 equals to 0.4 times 1.5 C. So C is 0.6. So half ln A is equals to 3.32. Okay, there we have it. Find the exact value of this integration. So this is 1 x. Now, usually in this instant, it will be integration by parts. That's because there's a mixture of functions. So you have to be careful. You can differentiate ln x, so you put u as ln x. dv as x to the power half dx. So du over dx equals to 1 over x. So dx is correct this. Du is 1 over x dx. Du equals to 1 over x dx. So by integrating this, you get v equals to x, well, 3 over 2 over 3 over 2, so it will be 2 over 3. So this is u dv equals to uv 3 over 2 over 3 ln x minus v du. So it is v times du, integrate. Now I like to do all this first. This is 2 over 3 x to the power half. Before I put in all the values. 2x power 3 over 2 ln x minus 2 over 3 is x 3 over 2 over 3 over 2 again. 4, 1. Okay. Now what I'm going to do is I'm going to simplify first before I substitute the values. Minus 4 over 9 x power 3 over 2. 4, 1. Okay. Now substitute x by 4. X 4 to the power 3 over 2 is 8. 2 times 8 over 3. 16 over 3 ln 4 minus 4 to the power 3 over 2 again. This is 8. So this will be 32. 9 minus ln 1 is 0. So this is minus 4 over 9. So you have 16 over 3 ln 4 minus 28. Yes, there we have it. Curve has equation y equals to cos x sine 2x. Find the x coordinate of the stationary point in the interval 0 to half pi. Give your answer correct to 3 significant figures. Finding stationary point, you have to differentiate. This is product rule, uv. Whole cos x differentiate sine 2x is 2 cos 2x. Plus whole sine 2x differentiate cos x is minus sine x. So you have 2 cos x cos 2x minus sine x sine 2x. Okay, so do you want to find the x coordinate of the stationary point? There's only one stationary point. Okay, so what I'm going to do is I'm going to substitute your cos 2x with 2 cos square x minus 1. 2 cos x 2 cos square x minus 1 minus sine x 2 sine x cos x, which is sine 2x equals 0. So you have 4 cos cube x. Now, this seems a bit long, so I've noticed a pattern. This is a compound angle formula again, because there's 2. There's a 2. Cannot be. So you have no choice but to use. So again, I'm going to do. So there's no pattern. So what I'm going to do again. 2 okay. 2 okay. Sometimes things don't want to come up. 2 cos x 2 cos square x minus 1 minus sine x 2 sine x cos x equals 0. So you have 4 cos cube x minus 2 cos x minus 2 sine square x cos x. Substitute sine square x with 1 minus cos square x. Okay. Choice you have to do the long way. This is minus, minus plus 2. So this is 6 cos cube x minus 4 cos x. Substituting, factorizing. So you have cos x, 2 cos x, 3 cos square x minus 2. Okay. You have cos x equals 0. Cos x 0, x is half pi, but it cannot be equal to half pi. So there's no solution here. Then you have cos square x equals to 2 over 3. Cos x equals to, because it is in the first quadrant, I'm going to use the positive solution. Okay. Shift cos square root of 2 over 3. So it's 35.3 degrees. That is the solution. There's only one solution between 0 and half pi. That's it. Express root 3 cos x minus root 3 sin x in the form r cos x plus alpha. Give the exact value of r and the value of alpha correct to 3 decimal place. So in this instance, you can refer to MF 19. R would be square root of root 2 square plus root 5 square. So this is 2 plus 5 is root 7. Alpha would be arctangent root 5 over root 2. Okay. .688 degrees. Yes, correct to 3 decimal place. Hey, such a simple solution. Simple question. Huh? 3 marks. The diagram shows the curve of y equals to x. I'm not sure if I miss anything. No, that's all. Okay. Okay, I think there's a question B which I need to look for. Okay. Hold on. Question is not just hasn't finished. Okay. Okay. We have it. Question B. Hence, solve the equation. Okay, between 0 and 180 degrees. Just be careful, huh? So we have root 7 cos x plus 57.688 equal to 1. So x plus 57.688 equal shift cos 1 over 7. So you have 67.8 degrees. I'll put it in 3 significant figures. 67.792 degrees. Okay. Mm. 0 to 180, there will only be one solution. Oh, okay, sorry. This is 2 theta. My bad. So this is 2 theta. So what I'm going to do is, the next is solution in the 4th quadrant. 292.208. 2 theta equals to 67 minus 67.692, sorry. See, when you play with too many decimal places, it's a big headache. So this is 10.104, 292.208 minus 57.68. This is 234.52. Theta is 5.1. Put all this in one decimal place, since they did not mention. So 117.3 degrees. Okay, that's it. The diagram showed a curve y equals to x over 1 plus 3x power 4 for x larger than equal to 0. And its maximum point is m. Find the x coordinate of m, giving answer correct to 3 decimal place. Now again, finding the maximum, you need to differentiate. So to differentiate this, you need to use the quotient rule. So you refer your quotient rule to in your F19. So this is u over v. So it's v du dx. Differentiate x is 1 minus u dv dx. So this is 12x cubed over v squared. Okay, so finding the maximum, dy dx is 0. So this will be 1 plus 3x to the power 4 of x to the power 4. 3x. Okay, so the numerator will be 0. So 3 minus 12 is 9. So 9x to the power 4 equals to 1. 9. So there's a positive and negative value. Since m is negative, is a positive, x coordinate is positive for m. So you want in 3. Okay, 3 decimal place. 1 over 9. The power of 1 over 4. 0.577. Okay, there you have it. And solve the equation. This one, just now. Using the substitution u equals to root 3x squared, and find by integrating the exact area of the shaded region bounded by the curve, the x-axis, and line x equal to 1. So the area is basically this, from 0 to 1, since the line x equals to 1, y dx. So it's 1x over 1 plus 3x to the power 4. Okay, so what we're going to do is substituting u with root 3x squared. So du over dx is 2 root 3x. So dx equals to du over 2 root 3x. Okay. Here you get u square is 3x to the power 4. So when x is 1, u is root 3. When x is 0, u is 0. So by substituting everything, you get root 3, 0, x over 1 plus u square du over 2 root 3x. So you cancel off the x. So this is equals to 1 over 2 root 3. 1 over 1 plus u square du. So using your MF19, integration of 1 over 1 plus root 3 is arctangent u. So this will be 1 over 2 root 3 arctangent u 3 0. Okay, 1 over 2 root 3 tangent of root 3 is pi over 3 minus arctangent 0 is 0. So I'm going to times by 3 over root 3. This is to rationalize. Huh? Hey. Sorry. I canceled the wrong thing. So basically you have root 3 over. So this is 2 times 3 times 3 like 18. That's your answer. Okay. Exact area. That will be the exact area. So I need to put unit square. Okay. Variable x and y satisfy the differential equation given that y equals 2 and x equals 0. Solve the differential equation expressing y in terms of x. Yes, y in terms of x. Separating the variable. So you have dy over y minus 1 equals to dx over x plus 1. So before I continue and integrate, on the right side, the x need to change it to partial fraction. So what I'm going to do is I'm going to change it to partial fractions. A over x plus 1 plus b over x plus x plus 3 x plus 1 equals to 1. Let x equals to minus 1. To a equals to 1. A equals let x equals minus 3 minus 2b equals to 1. B equals to half. I'm going to write it out again. Form which is easier to see. Oh, I've got to write smaller, or else I don't have any space. Half 1 over x plus 1 minus 1 over x plus 3. Okay. Dx. So this will be ln y minus 1 equals to ln x plus 1 ln 3 plus c. So you are given y equals to 2 and x equals to 1. X equals to 1. Save some space, excuse me. So this is ln 1 would be 0 equals this is 0. Half ln 2 half ln 4 plus c. So half ln 2 minus half ln 4 is half ln half. So this equals to c equals to minus half. Okay, or half 2 2. So you want y in terms of x. Okay. So ln of y minus 1. I'm going to put everything together because everything has a half. Half ln 2x plus 1 over 3. Okay. So y minus 1 equals half, bring it up, becomes power of half, it will be a square root. 2x plus 1 over x plus 3. And the 1 over, so to save some space. That's it. You have the solution. Solve. See that? Oh, 9 marks. Solve the equation 1 plus 2iw plus iw conjugate equals to 3 plus 5i. Oops. Okay. Give your answer in the form x plus iy, where x and y are real. Okay, you're given w. W equals to x plus iy. So w conjugate will be x minus iy. You're asked to find what is w. 1 plus 2i x plus iy I x minus iy equals to 3 plus 5i. Here what you need to do is you need to equate the real and imaginary part. And solve simultaneously. 2i times iy is minus 2y plus ix plus y. I square is negative 1. Simplifying x minus 2y plus y is x minus y, which is the real part, plus I. So this will be 2ix plus ix will be 3x. 3 plus 5i. Okay, so here you have x minus y equals to 3. 3x plus y equals to 5. Equating the real and imaginary part. So you add, you get 4x equals to 8x equals to 2. Substituting x, you get 2 minus y equals to 3, y equals to minus 1. That's it. So w, 2 minus I. On the sketch or an Argand diagram, sketch the region whose points represent complex number z satisfying the equation. So this is z minus 2 plus 2i, which will be the equation with the center 2, 2 and the radius 1. This will be in the center of rotation 4, 0, no, 0, 4, not 4, 0. 0, 4, and the angle is minus a quarter pi. Okay, so think it's the positive part. Real, imaginary. So this is 2, 1, 2, 2, 1, 2, 2. So 4, 3, 4, 3, 4. So you have 2, 2, which the radius 1. So try draw a circle. Okay. Z minus 4. This is the center of the circle. 0 degrees. So minus 1/4 pi would be here. Okay. So it's larger than minus 1/4 pi will be to the upper side of this line. And smaller than, so the region is in this here. Okay. Find the least value of imaginary of Z. So Z will lie in the shaded region. So the least value imaginary Z for points in the region giving answer in the exact form. To be here. Okay. This will be 1/4 pi. 1/4 pi. Okay. So you got to find this angle here. This angle. Okay. So what do you know about the angle? So this line here, this line is the horizontal of the square, 2, 2. So it's 2, 2. This radius is 1. So let's put this angle as theta. Okay, tangent theta is 1/2 root 2. Okay. They want the exact form. Okay, sorry, I want to find the angle. In fact, they want just the imaginary of sec. So it's just this point here, the least value. So if you look at here, the least value, this okay. Okay. So you want this here. This is the imaginary value. Okay. So you still need to find the exact value. So this is 1. This angle is 1/4. So you need to find this x here, x. Find the value. Okay. So I'm going to change a bit. this. Okay, so it's cos. Cos 1 over 4 pi equals to x over 1. So x is cos over pi is root 2 over 2. Okay, so the least imaginary z, least be 2 minus x. Root 2. Okay, there you have it. The diagram show the curves y equals to cos x, y equals k, or 1 plus x, where k is a constant. X is between 0 and half pi. Curves touch at the point x equals to p. Show that p satisfies the equation tangent p equals to 1 over 1 plus p. So you have cos p touches okay. This seems to be a very tricky question. So you have a tangent p and the cos only. So in the first place, if they touch, the y coordinate must be the same. Huh? So cos of p, which is equals to k over 1 plus p. Okay. I need to show there's no k. You need to be able to eliminate k. So if it touches, means gradient at that point is also the same. So dy over dx is also the same because gradient is same. So for the cos x graph, differential is minus sine x. So it's minus sine p equals to differentiate k over 1 plus x is minus k x squared. Huh? Okay. So cancel off this minus. There you have it already. Huh? So you have a sine p and a cos p. So when you divide sine p divided by cos p, you get tangent p. You have k over 1 plus x square. Oh, sorry, this is p. Huh? I forgot to substitute p. Over k over 1 plus p. Okay, there you have it. So here you can cancel here, and then this cancel the power. So you have tangent p 1 over 1 plus p. Okay, well, this question is very tricky. Use the iterative formula. Pn plus 1 equals arctangent 1 over 1 plus p. To determine the value of p correct to 3 decimal places, give the result of each iteration to 5 decimal place. So if you're unable to prove question A, you can always move to question B. So I always like to use table. N, P, N. So this, when N is 1, so its answer is between 0 and half pi from the graph. So I'm going to use the first iteration, P1 will be 1/4 pi. Okay. So what is P2? Let's move. Now use your value of your calculator to the fullest. Okay. So this is arctangent. Answer must be in radian, huh? So I'm going to change the mode to radian. Okay, so this arctangent 1/1 plus b. So, okay, so they want it in 5 decimal place of 0.51056. Remember to use a calculator to the fullest. Next iteration 0.58477. The next iteration is 0.56291. Next iteration is 0.56919. Next iteration is 56737. You want your answer to 3 decimal place, so you have to continue until it is nearly the same. 56790. Oh, this is going to be long. 56775. 779. We're going to be there already. Okay. Okay. So your answer P is 0.56. Okay. Hence find the value of K correct to 2 decimal place. So cos P is K over 1 plus P. Substituting the values of P with 0.568. So it's 1.568 times cos of 0.568. 1.32. That's it. Okay. Vectors. Oh, this is now a simple question. And now I put it in question 10. With respect to the origin O, the points A and B have position vectors given by OA 6i plus 2j and OB is 2i plus 2j plus 3k. The midpoint of OA is M. The point N lying on AB between A and B is such that AN equals to NB. So I'm going to make a simple drawing. 0, A, B. Midpoint of OA is M. Point N on AB, AN equals to 2NB. Ratio is 2 to 1. Find a vector equation or line through M and N. So you got to find the position vector of M and N. Okay. So OM, I'm going to write it in column vector form. So its half is 310. So AB, AO, which is minus 6 minus 20 plus OB, 3. So this is minus 403. Okay, so ON is equal to OM OA, sorry. ON. OA is 62 plus 2 over 3 AB. ON is equals to 6 minus 8 over 3. 6 times 3. So it's 10 over 3. 2. 2. It's ON. What is MN? MO plus ON. This is minus 3 minus 1 O. 10 over 3, 2. This will be 1 over 3, 1, 2. Okay, so that is the directional vector. So I can always write the direction by multiplying by 3 is the same direction as 1, 3, 6. So the vector equation R is your position vector. Take OM, which is 310, as direction vector 136. That's it. The line through M and N intersect the line through O and B at the point P. This one will come here and intersect here at P. So you have N, M, O, B, and intersect at P. Find the position vector of P. Find the position vector of P. Two, three. So the vector equation OB is K at T. 2, 2, 3. Position vector just now we have is 3, S136. Okay, so you want to find the point of intersection. The x coordinate is the same. 2t 3 plus s 2t also. And 3t equals to 6s. So from these two equations, you get 2s minus 2 s equals to 1. So when s equals to 1, t equals to 2. So this consistent. So the position vector of P, this is when t equals to 2. So OP would be 4, 4, 6. Okay. Calculate the angle OPM. OPM. Giving your answer increase. So OPM. Okay, OPM will be this angle. So what I'm going to do is I'm going to do a dot product of OP and PM, or OB and EN also can. OB and MN. OB is dot product of OB dot MN equals to magnitude of OB times magnitude of MN or cos of the angle. Okay. OB is 223 136 equals to, oops, this is the magnitude. 2 square plus 2 square plus 3 square times 1 square plus 3 square plus 6 square. Okay. So this will be 2 plus 6 plus 18. 4 plus 4 plus 9, 8 plus 9 is 17 times root of 36 plus 10, 46 cos theta. Solving this equation, you get theta equals degrees. Shift cos. I want to give answers all sometimes radians, sometimes degrees. 26. $21.6. 21.6 degrees. Okay. That's it. We have finished. If you like today's paper, you can always subscribe to my channel. Like, put a comment if you need the paper, put your email address, and I will send it to you. Bye for now.